this is the last video that will show you the answers for your quiz. So these are the answers for Module 8's quiz. So we'll go through the quiz one by one like we have before and walk through any issues that you may have had when you were taking the Module 8 quiz. So question 1 was pretty basic. What's the difference from multivariate OLS regression and logistic regression? It has to do with the dependent variable. OLS regression has a continuous dependent variable, while multivariate or while logistic regression has a dichotomous dependent variable. Second question, question 2, asks you to recode the variable patrol, non-patrol. So 1 equals patrol, non-patrol equals 0, and then report the valid percentage for patrol. So what you do is you come down here and look for patrol v non-patrol, and it's right here. You have to see how it's originally coded first. So you see it was originally coded 1 patrol, 2 non-patrol. So we have to make it 1 patrol and 2 non-patrol, now a 0. So transform, code in different variable. And you find that here. And what I always do, change that. Old and new values, 1 is staying 1. Remember to go ahead and add this system or user missing and system missing. And then 2 is now 0. Add, click continue, click OK. So you get that file, get rid of that. Again, analyze it to find your and your descriptors and frequencies to make sure it was done correctly. Pull this over so you guys can see it. There you go, patrol v non-patrol, the original, and then recoded. We'll see here. That it was recoded correctly. Also, you can see I made the mistake. We'll go ahead and close this, but I made a mistake in the variable view that I did not come back here and go 1 patrol, 0, click OK, come back, reanalyze this. It'll just make it easier to see. And you can see that these have been recoded correctly because patrol had 63 and now patrol has 63, non-patrol had 65, non-patrol has 65. The valid percentage of patrol is 49.2 on your quiz. The next thing that the quiz asks you to do is run a multiple OLS regression with time-based work-family conflict as your dependent variable and years, law enforcement, number of kids, and your dichotomous patrol non-patrol variable you've just created as your independent variables. So you're going to go to Analyze, Regression, Linear. Again, always switch this. Just makes it easier. Time-based is your dependent, and then it asked for years law enforcement first. So years law enforcement, number of kids, and that recoded that you just did into a dichotomy of patrol v non-patrol. Run a regression. It asks you what the adjusted R-squared is and to interpret it. So the adjusted R-squared is right here. Adjusted R-squared is 0.212. To interpret that, multiply it by 100. So now you have 21.2. So 21.2% of the variation in time-based work-family conflict is explained by years law enforcement, number of kids, and whether or not somebody has a patrol or non-patrol job. Question 4. Ask which variables are significant or non-significant. So you're going to pop down to the coefficients table and look at the significance levels. So at first question 4 asks which variables are non-significant. How do you know? Number of kids is non-significant. It's right here. Remember, in order to be significant, it has to be less than 0.05. 0.550 is quite large compared to 0.05, and so it's non-significant. Question 5 asks you which of these variables are significant. And if you look here, you see that you have Also non-significant is recoded patrol. Sorry, it also has 0.311. Question 5 asks which is significant. Significant is years in law enforcement. It's 0.001, so that is less than the 0.05 cutoff value, so that is a significant relationship. Question 6 is moving along. Just ask you to interpret that significant relationship. This is a negative relationship, as you can see by the negative sign. So this means as years in law enforcement increases, time-based work family decreases. So that is the OLS portion of the quiz. Question 7 asks if you would ever have to dummy code the variable supervisor. So if you come to supervisor, click on the values, you see that it's already coded 1, yes, supervisor, 0, no, not a supervisor. That does not have to be dummy coded because it is already coded as 1 and 0. Next question, question 8, asks you to run a logistic regression with the recoded patrol, so the recoding that you did earlier in the quiz as your dependent variable, and the number of kids, education, and years law enforcement as your independent variable. So you come to analyze, again go to regression, go to binary logistic, move those over. Again, you're going to use your recoded non-patrol as your dependent variable. And then you're going to have number of kids, education, and years law enforcement as your independent variables. All right. Question 8, after you do that, after you run this, ask you to find the Nagle-Kirky R-squared and to interpret it. So again, you're going to scroll down a little bit. You'll see the Nagle-Kirky R-squared is right here. It's 0.607. Again, multiply that by 100, and now you can say 60.7% of the variation in whether or not somebody is a patrol or non-patrol position is explained by knowing the number of kids they have, the amount of education they have, and the years that they have been in law enforcement. Question 9 asks you to determine which variable or variables are significant. So you're going to come down to the variables and equation model. Again, you're going to look at the significance here, and you will see education and years law enforcement are significant because the significance level are less than 0.05. Number of kids is non-significant. It asks you to interpret as well these significant relationships. So with education, it's negative. So as education increases, the likelihood you're on patrol decreases. And then as year in law enforcement increases, because it's also negative, likelihood on patrol decreases as well. Question 10 is just a little thinker to let you guys guess where you'll be in 5 years. I'll give you a little information. In 5 years, I hope I have tenure and I am still continuing at Xavier. I love my new job. Well, it's not really new. I've been here for 3 years now, but I love the students at Xavier and the faculty and the staff at Xavier. And so 5 years from now, I hope I am a tenured professor at Xavier. Thank you all for a great 8 weeks. I know statistics and methods are pretty difficult online, particularly when we have to rush statistics and methods together in 8 weeks. You guys were all fabulous. You were great. Thank you for your hard work. You gave really good effort in the discussion boards, and it was a joy to have you guys these past 8 weeks. I'm looking forward to seeing you in the summer for your thesis class. Thanks, and have a good weekend.